Okay. What we do, we're going to end up using division. Well, how we're going to use this next week is we're going to end up using division as another way to find some of our zeros. This long division, we'll do the long division first. The long division is just like, when you learned how to do regular long division. It's set up the same way. So when you take this polynomial here, 2x to the fourth plus 3x to the third plus 5x plus 1, divided by that, you write it out just like if you were going to take, 500 divided by 3. You write it out the same way. So you write out 2x to the fourth plus, oops, well, that's not real clear there. So 2x to the fourth. I'll try and get that nice and neat there. So 2x to the fourth plus 3x to the third plus 5x plus 1. And what you want to do is, if there is a term missing, like in other words, there's an x squared, there's not an x squared term that's missing, we'll put in a 0 there. So that's a little bit different. So I'm going to put a 0x squared. And we're going to take that polynomial and we're going to divide it by, we want to know how many times this goes into this. So we're going to divide it by x squared minus 2x plus 2. Okay? So that's how you write it. Now, here's the key. In order for this polynomial over here to go into this one, we're going to do it into these three terms first off. Okay? You do these three terms going into these three terms. And the first thing you do is you want to match this first term. So in order to match 2x to the fourth, we would have to multiply this by 2x squared. Good job. Yep. So that's what you put up here. Okay? Because in order to match 2x to the fourth, we need to multiply x squared by 2x squared. Okay? And then you multiply all three of these terms by that 2x squared. So you multiply the first one, and your first term always has to match because you want to be able to subtract it and keep making it smaller until you get down to the end. So the first term always has to match, and then we take our 2x squared times negative 2x, so that's negative 4x to the third. So your exponents always match up too. X to the third and x to the third. That way you can subtract them. And they're like terms. If they weren't like terms, you wouldn't be able to subtract them. And then 2x squared times 2. So that's 4x squared. And then, like I said, just like regular long division, we subtract those two. So 2x to the fourth minus 2x to the fourth. That's just 0. That's gone. Here's where you got to be a little bit careful. 3 minus negative 4. So yes, it's going to be 7x to the third. And then 0 minus 4. That's why it's important to put in a 0 if there's one of the terms missing.
Plus 5x plus 1.
Okay. Now we're only going to bring down, we can only do 3 terms at a time. So we're just going to bring down the 5x. Okay. And now we follow the same process. We want to match the 7x to the third. So now we're going to multiply. We're still looking at our first term because we want that first term to cancel out so that we keep getting it smaller. So 7x, yes. So we want a positive 7x. So we put plus 7x. Now same process, you multiply that by all three terms. So we got 7x to the third minus 14x squared plus 14x. Good job. Yep. And then we subtract those. Okay, so you're right. Good job. And then we carry down our 1. So now we want to multiply by 10, positive 10, because remember, we want to match this first term down here. You always want to match that first term, because then you can get rid of it, and then it gets, like I said, keeps getting smaller. So you multiply it by positive 10. So if we multiply all three of those, then we're going to have 10x squared, and then minus, and then plus 20. Oops, oh, it does that. We subtract those. Good job. 11x minus 19. I don't know why that's a little wiggly, but okay. So that's, it won't always come out even. So this is our remainder. That's what's left over. So how you do it, how I want you to write it, so this is our remainder. And how I want you to write your answer, let me just give you a side example here. Say we do a smaller one, just like regular long division. Say if we did something like, I don't know, like say 63 divided by 4, let's say. Okay? Another way you can think of that is 63 fourths, because it's 63 divided by 4. That would go into here once. 6 minus 4 is 2. Goes into 23 5 times. Oops, let me move this over. So your remainder is 3. Remember you'd write like R3. How I want you to do it, what's another way that you could write 63 fourths? Yes, good, Mitch. 15 3/4. You take your remainder and you put it over what you're dividing by. 15 3/4. So we're going to do the same thing here. We're going to say 2x squared plus 7x plus 10. I'm just going to add on my remainder. So plus 11x minus 19 over my x squared minus 2x plus 2. So in other words, this is what was left out of how many times this went into it. So you just take your remainder and put it up there. Yes. Oh, maybe. Okay, thanks. Okay. So this would be your whole answer. Okay. King high. Okay, that's a good question. Again, we always want to match whatever the first term is. Yes. We had to times this one by the x squared. Yeah. And then here, I wanted to match the 7x to the third. So we have to multiply this by. You always decide what do I need to multiply this term by in order to match whatever term I'm trying to cancel out? So like here, I needed to multiply this by 7x in order to match the 7x to the third. And then here, I needed to multiply this one by 10 in order to match the 10x squared. Yep, that's a good question. Okay, let's do another one to practice. I'll have you guys see if you can do that. See if you can do the long division. Okay, so we write it out. Do I have to put in any zeros for any missing terms? Nope. Okay, so again, I want to match. We can only do 2 terms at a time because you can only subtract the same number of terms. So, and I want to match the x to the third because I want to be able to subtract that and cancel that off. So I have to multiply this x. I would have to multiply that by x squared because then I'll get x to the third minus 2x squared. Okay. And then we subtract those. So x to the third minus x to the third, those will cancel out. 2 minus negative 2, that'll be 2 plus 2, so that's 4x squared. Then we'll carry down the negative 6x. Now I want to multiply by positive 4x. So then now I've got 4x squared minus 8x. I subtract those. So these are gone. Negative 6 minus negative 8, so that's 2x. Then I'll carry down my 9. Now I just need to multiply by 2. You guys okay so far? Want me to redo that?
I know what I did wrong.
Okay, let me, here, I'll rewrite it. In order, this has 4 terms. We want to cut it down to 3, and then 2, and then, so you always need to keep cutting off your first one. So you're always looking at, okay, if my first term is x to the third, in order to get that to cut off, so I can cut it down to 3 terms, I need to figure out, okay, what do I multiply this first term by in order to cut off this first term? So this is x to the third. If I multiply this x by x squared, then it'll cut that term off. So I put my x squared right here. Just like if you have, and you have, let's say, 9. That goes into there twice, so that you put the 2 right above the 4. Like that. So this is the same thing. I put the x squared, so I'm going to go into these first 2 terms. So I multiply that x squared times that x. I've got x to the third, and then the x squared times the negative 2, so that's negative 2x squared. Like that. Then I subtract them. This first term, if you do it correctly, that first term always crosses out. And then you just have to be careful. 2 subtract negative 2. These 2 negatives will make a plus. So that's 2 plus 2. So that's where we get the 4x squared. And then you carry down another term. Because since this has 2 terms, we can only do 2 terms at a time. And now we're going to do, we got to match the 4x squared. So we would multiply this one by 4x, positive 4x. If, for example, if this was negative x, then we would have to multiply it by negative 4x. You know what I mean? So we've been doing positive ones, but So you put the correct sign right there. It's a positive 4x times positive x, so it's 4x squared. And then minus 8x. Those cancel. Negative 6 minus negative 8 is 2x. And then you carry down your negative 9. Now our last number would be 2. So then 2 times x is 2x. Negative 4. So negative 9 minus negative 4, negative 5. So then how I want you to write it is you'll write x squared plus 4x plus 2 plus 5 over x minus 2. Oh, is it negative 5? Sorry. I'll just put that. Okay. Now, there is a faster way to do it if you can't do it with like our first problem when it's like x squared minus 2x plus 2, but if you're dividing by a polynomial where this is just your coefficient on x is just 1, and then you have another integer. So like x minus 2, x plus 5, x minus 3, if it's in that form, there's a faster way to do it called synthetic division. Okay? So what you do, if I wanted to do this same problem, actually I'm going to do this one, but I'm going to show you synthetic division. You guys want one more to practice with long division? No. Because you can do them both ways. Tell you what, it'll only take a minute. Do this one by long division, and then I'll show you synthetic division. Do it by long. We'll kind of contrast the two methods. So stop here for a minute, see what you get. Now in this, switch up my colors here. Okay. Okay. Now, here's how the synthetic division works. A little faster. What you do, you put your bar kind of upside down, and you just have to put a little bit. We're just going to put down now. It's a faster way. Again, it only works. We'll look at this more next week. We'll just do this one, then we'll finish it up next week. It only works, the synthetic division only works if you're dividing by, like I said, something where the coefficient on x, you can't have any like x to the second, x to the third, x to the fourth. It only works if you just have a linear term, x to the 1, and your coefficient has to be x, and then some other integer. Okay? But if you do have that, it goes faster. What's that? No. No, that's a good. No. Has to be just, yes? So, if that's the case, you just put down the coefficients of the coefficients and then your constant terms. So I would just put down 1, 2, -6, and -9. You just put down your coefficients and then your constant term at the end. Okay? And then you just have to put down, now guys, from what we were doing with factoring, if x plus 3 was a factor of this polynomial, what would the actual 0 be? -3. So right here, you put your 0. whatever your 0 is. If it's a 0 of that, yeah, we're going to use this a lot. And you'll see it. When you do it a couple times, we'll do it more next week. It's not too bad. So that you put your 0. So it's x plus 3. But you know, when you set that equal to 0, your 0 is going to actually be negative 3. X is going to equal negative 3. Then what you do, we carry down the first number. Put that down there. Okay, that's a choice due to start out synthetic division. Negative 3 times 1 is negative 3. So you multiply those. So you just carry this one down, and then you multiply those. And then these ones, you add them. So it's a little different than the long division. So 2 plus negative 3, negative 1. And then we follow the same pattern, so multiply them. So negative 3 times negative 1 is 3. And then you add them. So negative 6 plus 3. Multiply them. 0. That's our remainder. Now, what you just do to write down your answer, this is always your constant. Then this is x, and this is x squared. So you have x squared. It always works backwards like that. So you just have x squared minus x minus 3, the same answer. Okay? So we'll do more with that next week.